Hello. Okay, you guys can hear me. Hi, welcome. Thanks for joining us. We're almost done. We got one more session, then we can go enjoy the party. Pretty awesome. Today, Alfred and I are going to talk to you about how Intuit optimized Kubernetes. So first, I'm going to go over our specific Kubernetes tooling system that Intuit uses to manage Kubernetes. And then I'm going to talk about how we allocate costs. And then I'm going to cover waste management, specifically with Kubernetes. And then Alfred is going to go over exactly what the IKS Central team did to optimize that waste. Hi, I'm Gina. I'm a principal business analyst at Intuit. I've been with Intuit for 10 years. I actually started in the accounting department, and then I moved to finance, where I was first exposed to hosting expenses. And now I've been with the FinOps group for about 4 years. And super interested if anybody is doing FinOps for AI. Love to talk about it like everybody, but we've been tapped to do it at Intuit, so would love to talk to you about it. And we actually also do all of the operational excellence metrics, our team, like availability, performance, incidents. And I haven't heard anyone else do that, so if you are doing it, come talk to me after this. But I'm a business analyst. How I introduce myself internally at Intuit is that I'm the employee liaison. So I help new engineers with forecasting their hosting expenses, how to use all of our internal tooling. I present our hosting KPIs to leadership, and then I work with sourcing to negotiate our cloud vendor contracts. I'll let Alfred.
Oops, sorry. Hi, my name is Alfred Tan. And I'm a development manager at Intuit. I'm getting some feedback. All right. Yeah, I've been with Intuit for about 19 years, and I'm currently leading the production engineering team. We are responsible for managing and operating the entire Kubernetes platform at Intuit. Getting some kind of feedback.
Okay, so a little about Intuit. We are a global fintech company. Our mission is to power prosperity around the world. And we aim to do that with these offerings you see here. So first we have TurboTax. They are the #1 best-selling tax software in the US. We aim to take the complexity out of the tax code and get you your maximum refund. Credit Karma is a top-rated, comprehensive fintech platform where we help members get matched to financial products to help them make smarter financial decisions. And a little plug, if you guys miss our Mint app, RIP, check out the Credit Karma Wealth section. You can link all of your all of your financial accounts and then set up budgets, calculate your net worth. It's pretty cool. So go check that out if you miss Mint. Next, we have QuickBooks. It's the world's leading small business technology platform. And so it helps small businesses run their day-to-day activities. So think like accounting, inventory, payroll, stuff like that. And then last, we have MailChimp. MailChimp is the #1 email marketing and automation platform. And we empower small businesses to start and then grow their business through marketing campaigns. Intuit first migrated into the cloud in 2011, where we brought over a couple of TurboTax instances. And we started the FinOps program in 2015. And we have since been pretty successful in the traditional FinOps pillars. We have solved for all of the major problems like optimizing prepay. We allocate out 100% of our costs. We have an effective waste management program, and we forecast at a pretty granular level. And we started using Kubernetes in 2018, and we developed the Intuit Kubernetes Services platform that same year. And we developed it internally. We refer to it as IKS internally. And I will also be referring to it as IKS because Intuit Kubernetes Services Platform is a mouthful, and I'm going to be saying it a lot. But what it is a Kubernetes managed service that automates the development, deployment, and orchestration of all of your container and serverless applications. And it has the ultimate goal of eliminating the burden from managing the cluster configurations away from the developers, and so they can just focus on coding awesome products. And so we would be classified in the run stage for that as well. And so double clicking into IKS, what IKS is, it sits on top of Kubernetes and it stitches together both AWS and Kubernetes to provide a compute environment that can host other applications and platforms that serve the products you see here. It hosts over 25,000 namespaces and 16,000 microservices using just a little over 300 clusters. And it's with 5 people that we have managing it?
Yeah.
So 5 people manage all of this. We started in 2018. It was then enhanced in 2020 when we migrated to the managed EKS underlying infrastructure. And more recently, we have been focusing on transitioning from cloud native to AI native, where we're aiming to integrate AI into every layer of our IKS platform. And so think code generation at the developer level all the way to an AI-powered UI component. And so we're hoping actually to triple developer velocity over the next few years with these AI components. And we're gonna do that via IKS Air. So let's briefly cover IKS Air. IKS Air is a type of paved road service that developers can choose during their initial deployment stage. It offers the core features that you see here, but what it is essentially is a pre-configured deployment repo where developers can input their application needs in an infrastructure technology agnostic way. So it decouples the infrastructure needed to run the application from the application needs themselves. And so I think of it like a restaurant and you're going to order a cheeseburger. So pre-air, you have to tell the chef exactly how to cook your meal. You have to say, take 8 ounces of lean ground beef, grill it for exactly 4 minutes on each side at 350 degrees Fahrenheit, and throw it on a sesame seed bun with lettuce and tomato, and maybe an over-easy egg if you're feeling really spicy. But you have to define exactly how to cook the burger. With Air, you just tell the waiter what you want. You say, I want a cheeseburger, medium rare, with lettuce, tomato, over-easy egg. And so that's infrastructure technology agnostic, right? I don't care how the chef is cooking the cheeseburger. He could be using a charcoal grill, a gas grill, flat top. All I care is that I get that cheeseburger. I had a light lunch, obviously. And so how you apply this to software development is this should significantly reduce the time to resolve issues and the learning curve of new developers. Because developers can push updates faster because they have progressive delivery, and more safely because they have automated rollbacks. So Intuit's going to use all of these features to hopefully triple developer velocity. So when you're a new engineer at Intuit, you have to take new developer training your first week. And in that training, we encourage them to adopt an IKS first mindset over other traditional AWS paved paths. And we do this because we want them to gain the benefits that IKS offers. So you really get all of these operational superpowers because you don't have to worry about container orchestration and you don't have to worry about scaling your applications. IKS just handles all of this for you. And so not surprisingly, oh, I think it skipped ahead. Yeah. Okay, hold on 1 second. Oh, I don't know, this got messed up a little bit, but that's okay. So not surprisingly, our IKS has had a substantial growing adoption over the past few fiscal years. So that pie chart is not supposed to be on the bar chart right now, so just imagine it's not. But in fiscal year 23, the IKS costs as a percent of total hosting costs was less than 10%. That grew by 50% in fiscal year 24. And now this current fiscal year, we're projecting to be over 20% of the total hosting costs. So it's growing substantially, but that upward trend really underscores the value and efficiency we're seeing from the platform, because now this circle chart would pop up. You would see that IKS is making up of more than 50% of our total core compute. So it has officially surpassed all of our other compute deployments. This is when it's supposed to pop up. Okay, so now you know why IKS is pretty awesome, and you know that it's our go-to compute option. Getting the costs accurately allocated would be pretty important, right? And so let's first talk about the fundamental challenge that Kubernetes presents us FinOps folks with. Unlike a single cloud compute, single tenant compute resource where the billing's fairly straightforward, Kubernetes is intentionally designed for simultaneous use by multiple teams. And so what we have to do as a FinOps folks, we have this raw cloud cost line that represents a single IKS cluster that has multiple diverse workloads running side by side. And so we need a way to logically separate these cluster costs. And so think about it like if you are sharing a big house with a lot of roommates and you get the electricity bill and you have to share these electricity costs. It comes in one big lump sum. But if you have Dean down the hall running a Bitcoin farm out of his bedroom, it's not very fair to split the electricity bill, right? If you're just like have a nightlight in your room. So you need a way to logically separate these costs. And so namespaces are a perfect supplemental method to do that. And luckily for us, the IKS management tooling system continuously tracks the underlying IKS cluster resource consumption at a per minute granularity. And so they make that data available for everyone at Intuit. And so think of things like namespace configurations, container utilization patterns, all of the namespace metadata that you need to do your cost allocation. So all of that data is made available for Intuit. And when we initially set up this process, we relied on taking cluster snapshots of this telemetry data twice per hour, and it was specifically at the 15-minute and the 45-minute mark. And while that worked reasonably well for long-running steady-state workloads, there were shortcomings specifically with short-running, less than an hour, bursty jobs. Because if you had a job that was running at the 16-minute mark and the 44-minute mark, our old system would completely miss that workload and it would result in zero cost attribution. And conversely, if you had a job that was really short, but it happened to run at the 15-minute and the 45-minute mark, that workload would be overrepresented because our system would think that would be running for the entire hour. So this led to some complaints, justly so, specifically from teams that had bursty scheduled jobs. And so we knew we needed a more robust, comprehensive system. And so we created a data pipeline. And the data pipeline was designed to capture this telemetry data per minute, at a per minute granularity. And so now instead of just 2 data points per hour, we have 60 data points per container per hour. And so it starts with the IKSM forwarder, which publishes container metadata every 60 seconds into our event bus topic. And from there, our data pipeline processes the stream and it pushes aggregated formatted data into S3. And from there, Airflow orchestrates the movement of data from S3 to our data warehouse, and we specifically use Redshift. And now the data is available for cost processing. And so now we have minute-by-minute data. We can perform a time-weighted distribution of these IKS costs. And we can allocate the cost proportionally to how long the workload was running and how much resource it was consuming. So that's really step one. If I go back, so this is step one of the allocation process that we do internally. Because remember, we developed this in 2018, so this is before any of the third-party tooling that exists today helps you with Kubernetes allocation. We developed this all pre-tooling. So step one, you have good granular data that's available for cost processing. The next step is to summarize your total cluster costs. And so think of the cluster, this box, as the complete financial footprint of an IKS cluster. We separate it into 3 specific categories. The first one is the Kubernetes control plane. So that is your managing brain of the entire cluster. And we have tags within that IKS telemetry data that tells us which resources are related to the control plane or not. Next, you have your worker nodes. Those are the nodes running the application themselves. And then you have your pods and containers underneath those. And then finally, you have your non-compute supporting services. So think of stuff like networking, storage, monitoring. And so we group these costs from the bill into these cost categories, and then we make these cost categories persist throughout our allocation process. So you can always go back and look at the workload, control plane, and non-compute of a specific IKS cluster. The next step is to assess the resource distribution. So this is where you use that per minute IKS telemetry data. And what we do is we aggregate all of the namespace, CPU, and core that's identified in the IKS tooling data. And so we can then use these CPU and RAM delineations to derive percentages. So now we just aggregate all of the specific namespace, CPU, and RAM to find the percentages that each namespace is responsible for. We then apply these percentages to the specific cost categories that we outlined in step 2. So now you have your cost per namespace, and you can see it broken out by workload, control plane, and non-compute. Part of other telemetry that I didn't mention was a vital link of namespace is asset ID. So when you configure a namespace in our IKSM, or IKS management tooling, you have to link your namespace with a valid development asset ID. And all of these assets live within our development portal. And so now that we have an asset ID linked to a namespace, we can see which dev manager is responsible for that asset or service, which cloud budget it belongs in, and then which business unit it belongs in. So that's very vital metadata that is linked to every single namespace. And then we process all of that information and we post it on our internal cloud cost tooling. We build all of these tools in-house as well. But so then from that cloud cost tooling, you can look up, if you're a dev manager, you can see all of your IKS costs. You can see the namespaces running at the asset level, at a project level. You can slice and dice the information in a lot of variety of ways. Okay, so now you know how we allocate costs. Let's move to waste sensors and effectively managing our waste. So at Intuit, we employ a variety of different sensors. We combine both the AWS out-of-the-box Trusted Advisor solutions and Compute Optimizer, and then we also build our own internal sensors as well. And so we have the cloud cost tools. We also have the savings opportunity dashboards that we manage internally, where we showcase all of this sensor data. And it looks a lot prettier than this. Our UI engineers are much more talented than I am at Google Sheet slides. But we showcase the waste at a sensor level, and we calculate the savings opportunity, aka waste, at a monthly level. So you can see how much each sensor you could save if you corrected each sensor. And then we also calculate the percentage of waste as a percentage of total costs. So we don't just showcase it at the sensor level, but also the leader level, because remember, every asset ID is linked to a dev manager. And so we actually show the org chart as well in the savings dashboard, and you can see the waste at every single level, and you can drill down into the org chart, which is pretty cool. And then also we have resource level data. So if you clicked RDS idle, for instance, on the dashboard, all of the resources that were driving that waste would pop up. So specifically with Kubernetes, we have 3 sensors that we focus on. The first one being container utilization. This sensor monitors the CPU utilization patterns of all of our running containers, and it flags any container that is consistently using less than their allotted CPU. And the action to remediate is either to terminate the container if you're not using it, or you can reduce your resource requests. The next one is dedicated instance groups. So you can kind of think of this like the shared versus dedicated tenancy within EC2. But when we first started using Kubernetes, we wanted everyone to be using dedicated. And that's because we didn't have a solid way to isolate an instance group. And so you had a noisy neighbor problem. And so everybody was using dedicated at first. But that issue was mitigated when the IKS team created pod security groups. And so now that we have pod security groups, there's really no reason to be in dedicated, and it's much more expensive. And there's other benefits of being in a shared instance group that Alfred's gonna touch on. So this sensor flags any instance group that is still on dedicated and we want them to move to shared. And we estimate how much they could save if they move to shared. And then finally, we have empty instance groups. So this is where you go into IKS, you configure an instance group, but you don't have any applications running under them. And Alfred's gonna explain how exactly that happens. But we flag these instances and they should be terminated immediately because they're completely wasted resources, right? And so when we looked at our waste at the end of last year, these 3 IKS categories made up 60% of our total waste at the company. So we knew we had a problem, and the IKS Central team made it a top priority in fiscal year 25. And Alfred is going to go over specifically what we did to mitigate this.
Thanks, Gina. Yeah, so basically the Intuit Kubernetes Service, or IKS waste sensors, they actually provide us cost savings opportunity in operating the IKS platform. We can actually drill down to any of these waste sensors and then be able to take a look at the clusters, the namespaces, and services that are contributing to these wastes. We also have those sensor actions that actually provide remediation steps for us in order to eliminate the waste. So let's take a closer look. Here's the IKS container utilizations. It's actually telling us to either terminate the container or right-size this, right? So ideally, what it's telling us to do is actually utilize the resources we've allocated for those containers or shut them down. So based on these informations, based on the waste sensors, we knew we need to create some kind of solutions in order to kind of operate IKS so it's gonna be more cost efficient. So you and I know that no matter what type of solutions we come up with, there's always gonna be a team out there that needs an exception, right? So in order to do that, we actually created an opt-out mechanism so that service teams can actually opt out of these cost savings initiatives. For example, if we're gonna be operating on a node level, right, or a namespace level, so what we're gonna do is actually have namespace annotations. So whenever our tools or scripts runs, we'll actually see those annotations and we're gonna skip them. So we also know that if for some reason somebody forgot to annotate their namespaces, or we actually executed this and it caused some problems, we need the ability to quickly roll back. So based on this, we actually started going after the empty IGs. So empty IGs are your empty instance groups. So why do we have them? So empty IGs are generally created because somebody wants to kind of create a new cluster, or they're trying to create a new cluster in a new region. And a lot of these things a lot of teams are actually migrating from EC2s over to IKS. So what they're trying to do is trying to set the the settings for the instance group to match whatever that they have with their ASGs, which is your autoscaling group, right? By doing that, they're actually not using the resources that they need now, but it's setting for something that they might need later. So it's a complete waste. So what we did was we looked at every single IG and checked to see if they have any pods running. If there's no pods running, we're setting the IG mins to 0. So there's really little risk for this, right? So all we're doing is setting the mins to 0, and so there's no traffic going on. It should naturally scale to 0. And then when they decide that they're ready for it and they wanted to kind of put some traffic on it, it should just scale out. We're not touching their max settings, so it should be pretty normal. It's going to scale out. Sure, there's going to be a delay in creating the new instances and then to host their pods, but they can make those adjustments as they needed. So when we actually did the scale-ins for the IGs, so basically every single IG that we're scaling in, we're actually saving those money for those costs for those IGs. So let's take a look at the savings. So here's actually a graph that shows all the empty IG waste that we have at Intuit. So when we actually executed this job, you can see that we actually reduced it by 100% for IGs, but these are different IGs, right? So today we're actually running this in both pre-production and production, and we have very, very little waste at Intuit. So next we went after the inactive namespaces. We chose 30 days just because we were going to target just the pre-production environment. So we debated between 30, 60, and 90 days. But since we wanted to target mainly the pre-production environment, we know we could take a little bit more risk. So what we did was we took a look at all the namespaces and checked for their traffic in the last 30 days. If there's no traffic, we actually delete their deployment and rollout objects. Right? By deleting the deployment and rollout objects, there's really no need for the namespaces to have any of their observability. So we're saving money on the metrics and logs as well. Right? And then by deleting the namespaces that are inactive, or we're actually optimizing our cluster level operations, which means that we only kind of need to manage only namespaces that are actually active, and there's no overhead of managing things that we don't need to worry about. So we talked about the namespace annotations earlier, right? So let's say somebody forgot to kind of annotate this and say they need to be exempted, and then we actually executed this. We ended up deleting their deployments and rollout objects. So what happens is we can quickly recover from this by, if you guys are using Argo, you can do just an Argo sync or run through your deployment pipelines. The reason why you can do this is because we're not deleting their namespaces, right? It's still running there, we're just deleting their namespace, their deployment and rollout objects. So let's see the savings for this. So based on this graph, you can see that the monthly cost of the inactive namespaces, and then when we actually execute this job, we saved about 40 to 50%. So today, we're actually executing this only in pre-production, and we've been running this for the past 2 years. And there's still a lot of services that actually have annotations in place. That's something that we continue to kind of work with the teams in order to kind of pull these waste down. So next, we actually started going after the dedicated instance group. So we use an open source instance manager that actually creates and manages our instance groups for our worker nodes. There was a need for network isolations in order for us to kind of run our service environments in the same cluster, right? So Gina kind of touched upon that. So as soon as we actually released our per pod security group that allows us to kind of do network isolations for those namespaces, we were able to kind of start migrating over to shared IGs. So with shared IGs, basically when we actually do that, we actually have better cluster utilization because pretty much every namespaces within that cluster is actually using the same IGs. And with IGs, we tend to kind of, with the shared IGs, we default to the most cost-effective instance types. What I mean by that is basically we have some kind of preferred instance type that actually gives us the best price performance. And then with shared IGs, we also have this feature where we're actually able to kind of support mixed instance types. So the way this works is if you actually have a preferred instance type, and somehow we're actually trying to kind of spin up that instance, but it's not available, right? It's going to fall back to our default instance type. So right now we have definitions up to 10 different instance types and across different regions and across different chipsets. So the different generation types, sorry. So across different generation types. So basically you can have instances running on Gen 7, Gen 6, Gen 5, Gen 4, and then if you're running on x86, you would be able to kind of run on AMDs or Intel, right? So this is actually a mix of your trade-off between cost optimization and availability, right? If we actually are looking for instances that we need on our preferred instances, they're not available, we'll fall back to something more expensive, but that's okay, right? The other thing too is what we're trying to avoid is getting iced, all right? So ICE is when you actually ask for a particular instance and it's not available. It stands for the insufficient capacity errors, right? So now, based on this, we know that you don't need to create any ODCRs, which is your on-demand capacity reservations, because we know we can kind of fall back on the default to the backup instance types. So based on this, when we actually executed the migration, right, we're working with service teams to kind of migrate a lot of their dedicated IGs to shared IGs. And for this particular namespace, we saw savings of about 20 to 35%. So today, we're running pretty much over 90% of our IGs on shared IGs. And we started most of this migration earlier this fiscal year, so around July timeframe. So next, we started to focus on container utilization. So we're actually using VPA. So VPA is your Vertical Pod Autoscaler. So VPA is actually an open source tool that allows you to kind of right-size your containers for CPU and memory. It uses pod usage pattern to kind of dynamically scale your pods. We are using VPA in auto mode, so which means that it's actually using we're letting the VPA updater and the VPA admission controller to kind of fully manage our pods so that they can make adjustments based on those resources. VPA, our implementation on VPA, we're not actually adjusting the limits. We're keeping the limits. We're actually only adjusting the requests. So with VPA fully managing our stuff, we're actually running more performance. We're optimizing the performance of our application and services. So things are kind of right-sized. So if they're only over-allocated, we're actually reducing the allocation to only the resources that we need. And if they're underutilized, then of course we're actually bumping that up so that we don't get any resource starvation. So let's take a look at the cost savings with VPA. So here's a namespace example where we actually enabled VPA. So based on this, we're seeing a percentage of between 30 to 50% savings. The reason why you see the difference is because we actually adjust the minimum percentage allowed for VPA to operate. So what we have is, in our end-to-end environment, we had it set to 30%. And in the rest of the pre-production environment, we have it set to 50%. So we are getting some savings, but right now we can make those adjustments and let VPA operate more on a larger scale if we needed to. So anybody here using VPA? Right, that's good. A couple of people are doing VPA. Are you guys running a VPA in production today? Nice. And so there's one team that's actually doing that. So for us, we're still running VPA in pre-production right now. So we're still learning from it. We've been running VPA for the past 7 or 8 months. So depending on our results, we'll kind of decide when we're going to move to production. So next, we started working with Carpenter. So Carpenter is also another open source tool. It's actually developed by AWS. So Carpenter is actually your Kubernetes cluster autoscaler. And it actually right-sizes your node based on compute resources. This is mainly your CPU, memory, storage. Right, and it also uses the pod usage patterns to kind of manage to right-size your nodes. So VPA right-size your compute and pods, and then Carpenter actually focuses on node. So let's say if you have unscheduled pods, right, and Carpenter will try to figure out where to kind of host these pods. So it'll look for the best, it'll select the most cost-efficient and the right size type of nodes to host those pods. So right now, we actually implement Carpenter in this particular cluster. When you take a look at it, we saw a savings of about 50 to 60%. So Carpenter looks pretty promising for us right now. We've actually just rolled this out for all of our pre-prod environment. So we've been playing with this for the last year or so, but then really did most of the migrations earlier this year. So we can't wait to kind of see the results of this. Anybody running Carpenter today? Wow, there's a lot of you guys running Carpenter. That's great. Anybody running Carpenter in production? Wow, you guys are ahead of us, so we'll actually get there as well. So I just shared all the cost optimizations that we've actually done for this year so far, but I also want to share how we actually manage and operate IKS. So let's start with cluster management. We actually have a product called Autopilot. It's actually responsible for managing all our releases, and it's actually responsible for rolling out all the changes, cluster upgrades across all our platform. So the releases that we manage are mainly, it could be a version, a Kubernetes version upgrade. It could be an IKS release. It could be your cluster add-ons, or even AMI changes, your Amazon machine images, right? So based on that, every release that we have has to be BDD tested, which is your behavior-driven development testing. It needs to be load tested and performance tested, and then we need to do chaos testing with it as well. So once those releases have been certified, Autopilot is responsible for rolling this out across all of our platform. So think of it like in software development, whenever you guys certify a certain release, it gets promoted between your environments. The way Autopilot does it, it does it in waves. So our waves definition could be a set of clusters within a region for a particular environment, right? The next wave could be the rest of the clusters within that region and that environment, and then we promote that all throughout until we get it all out. So next, I want to talk about resiliency patterns. So in order for us to manage the IKS platform, we need to kind of ensure that we have patterns that we can enforce. The patterns are really, really important for us because it allows us to kind of operate these things more efficiently. So we have patterns that we actually publish. We have policy defined, and then we're actually enforcing a lot of these policies. So depending on the violation to these the patterns, we will either ticket users to fix them, or we'll actually page them. So we have patterns like, are your services resilient to a graceful shutdown? Do you have HPA defined? Do you have PDBs defined? PDBs is your pod disruption budget, right? And if you have PDBs, are they blocking any cluster maintenance? So these are really important because in order for us to do cluster management, we want to operate at all times. So right now the Autopilot is actually managing these clusters during business hours and during peak business hours. So we can kind of take down any clusters, put it in maintenance, and just run through it. So next, I want to talk about AI operation excellence. So you can imagine with hundreds of clusters, tens and thousands of nodes, right? We have a lot of alerts to deal with. So we have a product that actually tracks all the life cycle of our alerts, so we know when they came in, we know how long it took us to kind of resolve those. We also have like any incident information regarding any incident that was open against the platform or AWS so that we can kind of react to those. So with the amount of alerts that we get, we actually have an AI auto investigation. So an alert comes in, the job of the AI is supposed to kind of go investigate what happened or who caused that, who triggered that alert. It'll provide the detailed information and exactly provide that to our on-call engineers so they can take actions. We even took a step further so that if some of these alerts are caused by the service owners, we will actually page them. So for example, we actually have a node that are actually shared disk space. And if we have actually a pod that's eating up all the disk, we will figure out which pod it is. We'll figure out which service is running on that pod. We'll find out who's the on-call engineer for the service, and we'll page them so they can fix that. So we didn't want to be the middleman anymore, so we wanted to kind of get to the bottom of who owns that alerts and who needs to kind of remediate for it, and then therefore reducing any MTTRs, right? At the end of the day, all the alerts are there for us to kind of resolve ahead of time to prevent any incidents from coming in. So we talked about cost optimization, right? So we talked about the empty IGs, the shared IG migration, and then also the container utilization with VPA and Carpenter. But there's a lot of other things that we actually did as well. So one of the things that we talked about was the preferred instance types, right? So what we meant by preferred instance type is that if there's new generation types that's being released, we need to kind of certify that. And then when we certify that, we need to make sure that we're actually getting the best price performance. right? If our workloads are not able to take advantage of these new hardware, then we're not gonna upgrade those instance types to the preferred types. So last year, a lot of focus was getting into the preferred instance types, right? So the other thing too we did last year was a lot of focus on EBS volumes, right? So we knew that running on the newer volumes was a lot cheaper and more cost effective. So we did a lot of migration from GP2 to GP3 and from your IO1 to IO2. So right now we have about 99% on GP3 and IO2. And then the other thing that we're also doing right now is we're trying to kind of POC some stuff with like Kube Janitor or Kube Green, be able to kind of look at your resource types in Kubernetes and based on the TTL that you have defined, be able to kind of clean those up. So next, I want to talk about continuous security. So at Intuit, we have a lot of security requirements. Any CVEs that comes in, we need to kind of be able to kind of patch this in a timely fashion. So you can imagine we have a lot of AMIs going through our systems being certified, and once it gets certified, it's actually being released. So we are actually pushing AMI changes like at least once a month, right? We also have like strict requirements that any of our nodes that are running, it can't be running more than 30 days. So with Autopilot, we actually have a way to kind of force the node rotations to ensure we cycle them out. So one of the things that we're using that feature is actually during like tax peak or something like that, right? So we have restriction periods where we don't want any of these guys to be actually be non-compliant. So we're actually forcing the node rotations ahead of time, right? Ensure that we can kind of run through the entire peak period and being compliant at all times. And lastly, we actually do chaos and game days. So we talked about making sure that every release that we do has to be chaos tested, right? So we actually have capabilities that we provide our service owners to do self-serve chaos. Here they can kind of kill their pods, they can kind of experiment with CPU hog, memory hog, or disk full. So any node operations, they have to go through the production engineering team because they don't have access, so we'll actually have to execute that with them. But we do a lot of game days as well. So some of the game days that we've done is actually evacuating regions, right? If a region goes bad, we should be able to kind of move all of our systems over to another region. We also tested things with AZ evacuation. So if there's a bad AZ, we want to move all our traffic away from that AZ. We've also experimented with network latency. So the other thing we talked about was the graceful shutdown, right? So one of the things that we did in one of the game days was we want to test for those graceful shutdown. So what we did was we took a look at every single service out there and in production, and we actually picked out their busiest pod. And based on those pods, we killed it. So we waited for it to kind of recover. When everything recovered on that same day, we looked at every single cluster, we picked the busiest node, and we killed that. Right? The reason why we're doing that is because it's really, really important for us to kind of operate the cluster. It actually should be able to kind of run normal Kubernetes operation because your pods and nodes could be evicted, right? They could be rebalanced, and at that point, you're going through the same thing. And we want to ensure that our systems are able to handle that. And of course, because we have to kind of manage the cluster, and because of all the cluster operations, we'll need that type of graceful shutdown. So that's all I have to share, but I wanted to kind of hand this back to Gina, who will talk about the cost savings initiative that we implemented and the impact, how it actually impacted our cost numbers.
Yeah, so let's see how it went. So to recap, at the end of fiscal year 24, the waste from these 3 IKS sensors were 58%. So we kick off the IKS cost optimization project in the start of fiscal year 25, and just in the first quarter, we're down to 52%. And so this is where you can see the most traction being made within the dedicated instance groups and the empty IGs. The collaboration from the IKS Central team, they were starting to reach out to everybody on dedicated, getting them moved over to shared so they can get those benefits. And then in Q2, this is where VPA is implemented, and you can see the container utilization start to decrease. This percentage is 45%, I want to say. And then in the last quarter, now that Carpenter mixed with VPA, we're reaching out to more dedicated instance groups. The waste is at 35%. So that is a reduction of 58 to 35%. That's 40%, which is awesome work. So I can't give you numbers, but you can imagine at the scale that Intuit operates, how many millions of dollars this resulted in. So this is a really awesome effort, and it's a testament to what a central IKS team can do with solid collaboration cross-functionally and with good data. That's all we have. Thank you.
Hey everyone, producer Andrew here. Thank you so much for watching and for your support. For more FinOps X 2025 content, go check out our YouTube channel. Like, subscribe, and leave comments and questions for all of our wonderful speakers. We appreciate your support.